Hello everyone. So let's talk about indexing in database management system. Like what is indexing, why do we need indexing, and how can we create an index of a large database file. So before we dive into the indexing, first let's talk about how the actual data is stored in the computer. So for example, let's take a table student. So this has a three fields: roll number, name, and age. As you can see, roll number is an integer, name is varchar of 50 characters, and age is integer. So we know that key integer takes around 4 bytes of memory, and varchar is like key how many characters are there. So depending upon it will require that much amount of memory. So let's suppose key at max it can have 50 characters, and each character take 1 byte of memory. So a name at max can take 50 bytes, and again age will take 4 bytes of memory. So to store one row, this one row will need 4 bytes from here. At here will only need technically 1 2 3 4 and 6 10 bytes for 10 characters, and here again we'll need 4 bytes for this. So but for this row we'll need for 18 bytes, minimum 18 bytes to store this row. And in the worst case scenario for this table we'll need 50 plus 4 plus 4, which is 58 bytes, right? So to store one row of this table we need 58 bytes of memory. And we already know that key entire data is stored in the hard disk. As we know we need to store database in a permanent storage, so that it even if there is a system failure or any other kind of issue, our data is remain safe. So entire data is stored in a hard disk. But how is this table, or how is this table is stored in a hard disk? To understand that the hard disk is, let's try to understand how hard disk works or how hard disk stores data. So we will not dive into the actual storage or the actual structure of the hard disk, but let's take an example. Let's suppose this is my hard disk. So this is the computer hard disk. So your file system, in the computer system, the file system a computer have, it what it does, it creates or it divides this hard disk into smaller blocks, something like this. The entire hard disk is divided into these small size blocks, and the data is stored in these blocks. So this one block can be of size, for example, it is usually 10 to 12 bytes to 2 kilobytes. It can range into this range, but everything in the hard disk is stored in these smaller blocks. So whenever we'll talk about blocks throughout the course, we are referring to these hard disk blocks where actual data is stored. So if we talk about how this entire table is gonna stored, let's suppose ki we have a hard disk where each block size is Oh, for example, let's suppose कि 150 bytes, this is the block size in the hard disk. So if one block can store 150 bytes, so how many records one block can have? Since we already know that one record will take 58 bytes at max, so number of records in one block will be 150, as it can store 150 bytes, and one record takes 58 bytes at max, so 58. So it will be around two records only. Two records can completely stored in this block. Now in this strategy we'll talk about कि one block one record can be kept in one block only. We will not split a record. For example, one record will not be splitted and kept into two separate blocks. So we'll not talk about that mechanism. That mechanism is known as a one spanned mechanism or in which one record can be split into two. One record can be split and stored in two different blocks, but the mechanism that we are gonna discuss in this course will be unspanned one, where record cannot be split. Record cannot be split. So if we are gonna store a record in a block, only when that entire record can be stored inside the block. So by this mechanism we can only store two records in one block. Okay, so this entire file, how many blocks will be needed for this entire file? It will be these first two records will be stored in one block, so let's call that block B1. Then next two records will be stored in block 2, and then next two records will be stored in block 3. Next two records will be stored in block 4, and next two record will be stored in block 5. So total 5 blocks are needed to store entire file. Okay, so total 5 hard disk blocks are needed to store entire file, which has 10 records only. So if it had, for let's suppose कि there were 10,000 records, then how many blocks will be needed? Then it will be 10,000 divided by 2, which will be 5,000 blocks will be needed to store a file which has 10,000 records. We are talking about with respect to only these three fields. So how many blocks are needed for a table depends on the size of one record, like how many bytes one record can take in the worst case, and how many records are there in the file. So but how does indexing comes in the picture? So what happens, let's suppose I want to search for a data. So let's suppose I want to find a data of a student of roll number 8, right? So for that, let's suppose you run the query of select star from a student where roll number equals to 8. So what we are trying to do here, we are trying to find the data of this student. Now we know that this entire file is split into small hard disk blocks, but we don't know where exactly this roll number is kept, right? We don't know exact block number where this roll number 8 is kept. So what we need to do, first we need to access b1 block 1 and check whether this stores the roll number 8's data. Then since it doesn't store, then we need to check b2 and then scan b2 and check whether it stores the roll number 8's data. If it also doesn't contain, then we need to check b3 and check again, then b4, and then we find the student data of roll number 8 in b4. So we need to check we might need to check all the blocks to find that particular data. So in worst case scenario, to find a particular data that we are trying to retrieve, your DBMS might have to check entire all the blocks needed, all the blocks which are storing the database file. And this can be very time consuming because here there are only 5 blocks, but as you can see for here there are 5000 blocks. So in worst case scenario, you might need to access 5000 blocks. So when we are trying to access a disk block, we need to access the disk. So imagine we need to access disk 5000 times, and this is what makes a database retrieval slow, because we know any operation you perform on the disk is very slow compared to operations being performed on the main memory, right? क्योंकि reading or writing data in the main memory is like it takes nanoseconds. So in the main memory, all the read write operations, they take time in nanoseconds, like 10-20 nanoseconds. But hard disk or secondary storage, it is so slow that all the read or write operations in the hard disk takes milliseconds. Of the time, like 10-20 milliseconds, which is very slow, around like thousands of times slower compared to main memory. That's where this indexing comes in. Entire goal of indexing is to make sure कि whenever we are trying to retrieve the data like this, we can reduce the number of disk block access to minimum, right? As less, so we want the disk block access to be as less as possible, because here we need to search for 5 blocks, right, in worst case. But if I can make an index which can tell me ki this is where your data is stored in b4, so then I'll only go to b4 and search that block only, instead of searching b1, b2 and b3 first. So indexing helps your DBMS to know where a particular record is stored in, I like it means in which disk block a particular record of the database is stored, so that instead of searching each disk block one by one, we can directly jump to that particular block and retrieve the data. This reduces the number of disk accesses and improves the search time in the DBMS. So that's all there is to, that's the purpose of indexing. Indexing is used to reduce number of disk block accesses. Okay, so there are multiple ways we can create indexes, and we'll talk about them in the upcoming videos. Okay, so let's stop here and we'll talk about how to create indexes in next video.